We've all experienced small electric shocks from static electricity. Little static shocks like this can be uncomfortable, but the shocks we can get from the mains can be deadly. Static shocks are like snapping an elastic band or shooting a water pistol at close range. Mains shocks are more like the feeling you get from the cord in a bungee jump or crossing a fast-flowing river. With a static shock, the amount of stuff that moves, like the elastic in the water, is fixed. There isn't very much of it, and it runs out in a fraction of a second. But with the mains shock, there's much more stuff, and it just keeps on coming. This means the energy shifted in each type of shock is very different. Static shocks involve relatively tiny amounts of charge, which shift tiny amounts of energy, so they don't cause any damage. But mains shocks involve millions of times more charge and can shift large amounts of energy, and that's what causes the harm. If we look at some typical figures, static shocks are very high voltage, several thousand volts, and high current, several amps, but they last only a millionth of a second or so before they run out of charge. So the current doesn't have time to shift more than a few thousandths of a joule. That's the energy shifted if you dropped a small pebble from waist height onto your toe. Mains shocks are at a much lower voltage, so deliver much smaller currents, but the charge available is effectively infinite, so the current will carry on for as long as you're in contact with the mains. In a few seconds, the current can shift hundreds or thousands of joules. That's the energy shifted if you dropped a concrete block on your chest or a fridge. So you really want to go out of your way not to get shocked by the mains. Typically, this means making any current that might flow through you as small as possible, which in turn means making your resistance as high as possible. Insulators like plastic or dry wood reduce any current if there was an accident. Conductors like water or metal would cause a bigger current through you. Here's a table of currents through you and their effects. With 1 milliamp, you get a tingling, which increases as you get to a few milliamps, which you'll start to feel as an unpleasant shock. As you get up to 100 milliamps, the pain becomes more and more severe, and your muscles start contracting uncontrollably, making it hard to breathe and harder to let go of the thing that's giving you the shock. Above 100 milliamps, the biological electric signals that control your heart and nerves begin to be overwhelmed, and without medical attention you may well die. Once the current reaches a few amperes, the energy shifted causes significant heating, so it burns your tissues and internal organs, and you're unlikely to survive. The good news is that it's quite easy to avoid being shocked. You simply keep away from anything live, so make sure live parts aren't broken, like in this plug, and don't connect yourself to the mains indirectly through spilled water or metal objects like forks. If you do accidentally touch the mains, then as we'll see, the wiring in your house has special features like fuses, circuit breakers, and residual current devices which cut off the live if there's a fault.